Let's look at a separations of variables problem. Here I take this very simple problem, dx dt equals x squared times t. Initial conditions x of 0 equals 1. And I'm going to use Sage to do most of the work. Notice here I say we must separate the variables ourselves. Unfortunately, Sage and probably just about any math tool out there doesn't really have the capability to separate in the way we want to. Because we don't exactly want to solve for t, we don't exactly want to solve for x, we don't exactly want to solve for dx dt, which we already have. So we have to do that work ourselves. But if we divide both sides by x squared, so we separate that way, and then go to our differentials, in other words, do the substitution for dx dt and get a dx, then what we have here is on the left hand side we'll have our dx divided by x squared, and on the right hand side we will have just the t left, and when we integrate with respect to t, of course, we have the dt. So these are our two sides, our left hand side of the equals and the right hand side of the equals, and so that we had to do by ourselves, and now we integrate both sides. And notice this is where, by doing this, our substitution of the differential, that is dx is equal to dx dt times dt, or again, the way many people think about it, although it's incorrect, is all we've done in separating the variables is taken this dt and multiplied both sides by it, so that's why we end up with the t dt here and the dx over x squared on the left hand side. Again, that's actually incorrect, but from an intuition standpoint is not a bad way to go. And so we get those two, and so the left hand side we want to integrate with respect to x, that's the dx part. So I have 1 over x squared, and I integrate that with respect to x. And then on the right hand side I integrate just the t, this t here, with respect to t, and then I'm going to add a plus c. So up here I'm using variables of x, t, and c, and here's my arbitrary constant plus c. And so then I assign that to x int and t int, and then I show what those are. So let's do that. That's what I would do first. And I see I get minus 1 over x squared on the left hand side when I integrate. Yep, the antiderivative of 1 over x squared is minus 1 over x squared, or 1 over x, sorry. And then I integrate the t, and I get 1/2 t squared plus my arbitrary constant. Again, I had to put that in, but there we have it. Now the next thing we would do is take that equation where we have minus 1 over x equals 1/2 t squared plus c. We would like to solve that, so I did that command already, and here I'm calling this the general solution. And notice this little trick I have. If I do an x underscore and then follow it by part of a word, an abbreviation, whatever, here I'm saying g underscore and then general, makes it the general solution. So what I'm going to do is solve that equation. So here's the left hand side is the x int, equals, double equals for true equals sign, and then is equal to t int, and I want to solve that equation for my x in terms of t. So and c, of course, because c will be in there too. So I do that command, I evaluate, and whoops, oh, I didn't undo the show part, so it did it, but it just didn't show me the answer. So now I do that, and I look here and I see that x is equal to minus 2 over t squared plus 2c. Awesome. So it did the integrations for me and then solve for x for me. Now it may or may not be able to solve for x, but I'll try to do another example that maybe is a little tougher, maybe involves an x squared or a log x or something like that. And so now notice this is in these square brackets. We need to work with just what's inside the brackets, and so the trick there is now in solving for c, I'm going to call this c solve, and what I do is I solve my new equation. Okay, so x equals minus 2 over 2 over t squared plus 2c. I want to solve that equation for c, so see, I'm saying solve, here's for c, but I need to do a couple of things. One is to get rid of the brackets around my equation. I say general, which we had assigned our solution to, our general solution, but I put it in brackets and I say 0 because I want the 0th or the very first item in those brackets. There is only one item, and that's the 0th item. So I do that, and then I say, well, yeah, but I need to substitute in my initial conditions. So I substitute in x equals 1 and t equals 0 because back here I had x of 0 equals 1. So if I'd only needed the general solution, if I wasn't given the initial conditions, I could have stopped up here by showing that. But I have initial conditions, so I substitute those initial conditions in into my equation, and I solve for c, and so I evaluate that. And you see I get c equals -1. Now that's also in brackets, so when I go to use that, I'll have to use that same trick of using brackets and 0. So now I get the full solution by substituting in for c. And so my solution here, again, I'm using that little trick I was saying, s underscore and then the rest of the word solution for my variable name. So solution is now in this case I take that general solution again, but I substitute just c. So I substitute c equals, oh, and I notice here, actually I guess it doesn't make a difference. I put a double equals up here and a single equals here, and it still works. So I guess I think we could have done either a single or double equal sign on these. I just now noticed that I didn't do those the same. So I guess the answer there is it doesn't matter. But I substitute in c, but notice I don't mess with the initial conditions anymore because I want the solution, not just something involving the initial conditions. So here I say take that general solution, substitute in my new value of c that I just found, and show me that solution. And I hit evaluate, and I come down here, and you see c was -1, and so I get my 2 over -2 over t squared minus 2 for my x. And there's my solution. So if I'm doing this with technology, I would need to certainly show how I solve for the left-hand side and the right-hand side with my separation of variables. I would have to show how I did that. Then once I did that, I integrate, and I would need to show the result of those integrations, and there they are. So I'm showing those, but I would write those down. Then I would need to show solving for x. Again, it's possible I may not be able to, but I show solving for x. Then I show my solving for c given the initial conditions, and I'd have to say that that's what I did. But then once I have c, I can substitute that back in, and I would need to finally show that solution. So you need to show all these answers to the intermediate steps in getting to your final solution. Okay, but you can use Sage to do all those intermediate steps. And the nice part there is I'm probably less likely to make a mistake in those calculations. Just doing antiderivatives, solving an equation, and so forth. So here's an example of using Sage to do a separation of variables problem. All right, so let's call that good.